Okay, so just to continue from our conversation about the standardized test statistic for large sample hypothesis tests concerning a single population mean, one thing that we need to move towards now is the whole concept and idea of observed significance. So the observed significance, or p-value, of a specific test of hypotheses is the probability on the supposition that the null hypothesis is true of obtaining a result at least as contrary to the null hypothesis and in favor of the alternative hypothesis as a result the actually observed in the sample data. So computational definition of the observed significance of a test of a hypothesis. The observed significance of a test of hypothesis is the area of the tail of the distribution cut off by the test statistic. All right, times 2 in the case of a two-tailed test. So what we're talking about here is we're talking about that area, the percentage out of 100, all right, that would be in those tails, right? So if it's a left-tailed, it's only one tail. If it's a right tail, it's the other tail. If it's two-tailed, then we're talking about both of them, okay? So the systematic hypothesis testing procedure of the p-value is as follows. First, we have 5 steps here. Identify the null and alternative hypothesis. Identify the relevant test statistic and its distribution. Compute the data, the value of the test statistic. Compute the p-value of the test. Compare the value computed in step 4 to the significance level and make a decision whether you reject if p is less than or equal to alpha, and do not reject if the null hypothesis, if p is greater than alpha, okay? And then you're going to formulate your decision based off of the context of the problem, right? So small sample tests, and this is one that I want to reiterate, this is not much different from what we have covered, but basically we learned that if you're dealing with a large sample test, whether the standard deviation is known or unknown, we're always going to be using the standard normal table or a z-score. But notice when the standard deviation is unknown and it's a small sample, meaning less than 30, then we have to use the t table, okay? Let's see here. Okay, and then we have the large sample test for a population proportion. So remember, you know, when we're dealing with a test statistic and we're dealing with the population proportion, there are 2 different ways to do it. This is the formula. This would represent the p with the hat over the top. Remember, we have that issue here on the slide presentation. But this test statistic does have a standard normal distribution. So this concludes chapter 8. What we're going to do now is move on to chapter 9. If you were to continue through these slides on your own, you would see your key terms that you need to know and understand in order to fully grasp, and then the takeaways for chapter 8.